The robot competition between China and the United States. Introduction. As we move further into the 21st century, the competition between China and the United States in the realm of technology has taken on new dimensions, particularly in the field of humanoid robotics. The rapid advancements in artificial intelligence (AI) have catalyzed a race between these two technological powerhouses, each aiming to dominate the burgeoning market for humanoid robots, machines that mimic human appearance and capabilities to operate in environments designed for human use. This report delves into the key developments, market dynamics, technological advantages, strategic implications, and future prospects of this competition. Key developments and market dynamics. The year 2024 marked a pivotal moment in the humanoid robotics landscape, with the World Robot Conference held in Beijing showcasing 27 new humanoid robot models. This event highlighted China's commitment to advancing robotic technologies, reflecting a broader trend where the humanoid robotics market is projected to reach $38 billion by 2035. Furthermore, estimates suggest that by 2050 there could be as many as 648 million humanoid robots in operation globally. This growth trajectory is fueled by the unique capabilities of humanoid robots, which can navigate human environments and utilize tools designed for human use, thus generating vast datasets that can be harnessed to enhance AI technologies. Technological edge. China's primary advantage lies in its manufacturing prowess, which allows for mass production of robotic technologies, particularly in sectors such as drones and electric vehicles. The Chinese government has identified humanoid robotics as a critical area for technological competition, aiming to fully integrate these robots into manufacturing and society by 2027. In contrast, the United States excels in AI research and software development, with companies like Nvidia leading the charge in developing foundational models that enhance the functionality of humanoid robots. These models utilize advanced AI capabilities to allow robots to learn from human demonstrations and adapt to real-world tasks. Learning and adaptation. Humanoid robots represent a significant opportunity for the evolution of AI capabilities. By embodying AI in physical forms, these robots can collect real-world data through interaction with their surroundings, effectively bridging the gap between simulated and actual tasks. Projects such as Nvidia's Project GR00T aim to leverage human demonstrations to train robots, enabling them to learn complex tasks more effectively. This capability is crucial, as many tasks that are straightforward for humans can pose challenges for AI, underscoring the importance of developing human-like learning processes in robots. Strategic implications. The competition for dominance in humanoid robotics has broad implications for global technological leadership. The United States must cultivate awareness of this race and adapt its strategies to maintain a competitive edge. This includes balancing innovations in AI research with a resurgence in manufacturing capabilities to match China's scale. Policymakers may consider implementing industrial strategies or tariffs to nurture the nascent humanoid robotics industry, ensuring that the U.S. remains a key player in this critical area of technology. Timeline of key events. 2022, advances in generative AI lead to significant improvements in humanoid robot development. August 2024, 27 humanoid robot models debut at the World Robot Conference in Beijing. 2025 projected, the humanoid robotics market is expected to reach $38 billion. 2027, China aims to fully integrate humanoid robots into manufacturing and societal applications. Conclusion. The race for humanoid robots is not merely a contest of technological innovation, it represents a critical front in the broader rivalry between China and the United States. Both nations are making significant strides, but their differing strengths, China's manufacturing capabilities versus America's technological innovation, will shape the dynamics of this competition. As the outcomes of this race unfold, they are likely to have profound implications for global technological leadership, economic power, and the future of work in the coming years. Sources of information. 1. Nicholas Wright. The global race for humanoid robots heats up. Foreign Policy, January 30, 2025. 2. The intensifying rivalry, China and the US in the humanoid robot race. PY Lessons, January 31, 2025. 3. The USA-China robotics competition, leading the race in innovation and global power. ResearchGate. This report encapsulates the ongoing competition in humanoid robotics between China and the United States, highlighting the stakes involved and the future trajectory of this technological rivalry. The competition between China and the United States in humanoid robotics reveals several counterintuitive insights that challenge common assumptions about technological advancement and economic strategy. 1. Manufacturing versus innovation. A prevalent notion is that technological innovation drives success in robotics. However, the competition illustrates that China's manufacturing capabilities provide it with a substantial advantage, while the US leads in cutting-edge AI research and software development. China's ability to mass-produce humanoid robots gives it a critical edge, enabling rapid scaling that the US currently lacks. This suggests that manufacturing scale can be as crucial, if not more so, than technological prowess in certain sectors. 2. Data generation from physical interaction. The idea that AI primarily relies on digital data is widely accepted. Yet, humanoid robots are set to transform this paradigm by generating vast new datasets through their interactions in the physical world. This counterintuitive perspective highlights that the embodiment of AI in humanoid robots can lead to more effective learning and adaptation by providing real-world data that enhances AI capabilities. The implication is that the future of AI may rely significantly on physical embodiments and real-world interactions rather than purely on virtual data. 3. Human-like learning processes. There is a common belief that AI can outperform humans in tasks that require logical reasoning or complex calculations. However, Moravec's paradox illustrates that many tasks that are easy for humans, such as everyday physical actions, are challenging for AI. The development of humanoid robots that mimic human actions can actually facilitate AI learning by leveraging human behavior as a model. This indicates that the future of AI development may be less about competing with human cognitive capabilities and more about mimicking human physicality and learning processes. For the importance of human form, it is often assumed that robots need not resemble humans to be effective. However, the race for humanoid robots demonstrates that a human-like form is advantageous for performing tasks in environments designed for humans. This counterintuitive insight suggests that the physical design of robots plays a critical role in their functionality and market viability, challenging the notion that robot design can diverge entirely from human characteristics. 5. Long-term value versus immediate gains. The competition reflects a longer-term vision where the potential value of humanoid robots far exceeds immediate market opportunities. For instance, Elon Musk's assertion that the long-term value of Tesla's humanoid robots could surpass that of its other ventures highlights a counterintuitive understanding of market dynamics. In technology, short-term investments might not correspond to the future value of innovations, suggesting that stakeholders may need to look beyond immediate returns to recognize the transformative potential of humanoid robotics. 6. Global strategic implications. While the competition is framed as a race between two superpowers, it may also hint at a broader shift in global power dynamics. The assumption might be that technological supremacy equates to economic dominance. However, the competition in humanoid robotics could lead to new forms of collaboration and interdependence, particularly in AI and manufacturing. This suggests that a more nuanced understanding of global power in technology is necessary, where competition can coexist with cooperative strategies. 7. AI transitioning into reality. It has been traditionally viewed that AI exists largely in the digital realm. Yet the humanoid robot race signifies a shift where AI is moving into tangible real-world applications. This transition challenges the perception of AI as merely a digital tool and frames it as an integral part of physical environments, thus altering the landscape of how AI is perceived and utilized across industries. In summary, the rivalry in humanoid robotics between China and the US offers several counterintuitive insights that redefine conventional wisdom about technology, manufacturing, learning, and global power dynamics. Understanding these shifts can provide a more comprehensive perspective on the future of robotics and AI. The competition in humanoid robotics between China and the United States is not only a technological race but also a strategic battle for future global leadership with significant implications that many may overlook. While the mainstream narrative often focuses on advancements in artificial intelligence and the direct applications of humanoid robots, several nuanced aspects of this competition warrant closer examination. 1. Market dynamics and projections. The projections regarding the humanoid robotics market reaching $38 billion by 2035 and the anticipated operational count of 648 million humanoid robots by 2050 highlight the enormous economic stakes involved. However, what many may overlook is the underlying economic and strategic implications of this market growth. The rapid expansion of humanoid robots could lead to shifts in labor dynamics, impacting millions of jobs globally. As these robots become integrated into various sectors, from healthcare to manufacturing, there will be substantial implications for workforce development, job displacement, and economic inequality. The significance of this market expansion also relates to the geopolitical landscape. Dominance in humanoid robotics could translate into substantial soft power for whichever country leads in this technology. The ability to export humanoid robots along with their technological frameworks could influence global standards and practices, thereby extending a country's reach beyond its borders. 2. Technological learning and adaptation. A critical yet often overlooked aspect of humanoid robots is their potential to enhance AI capabilities through real-world interaction. The concept of using humanoid robots to gather vast datasets from their operating environments is significant for the evolution of AI. As AI systems increasingly rely on extensive and varied datasets to learn and adapt, humanoid robots could serve as a bridge, providing real-world data that enhances the robustness and applicability of AI models. This learning process not only facilitates the advancement of AI but also raises important questions about data ethics and privacy. The collection of real-world data by humanoid robots, especially in sensitive environments like homes or hospitals, could lead to unforeseen ethical challenges related to surveillance, consent, and data ownership. The importance of establishing frameworks to govern these aspects cannot be overstated, as they will shape public acceptance and regulatory responses to humanoid robots. 3. Strategic approaches and policy responses. China and the US are employing markedly different strategies in this competition, which is significant. China's approach, characterized by state-led initiatives and massive investment in manufacturing capabilities, contrasts sharply with the U.S. focus on innovation and intellectual property. This divergence raises questions about the sustainability of each approach. While China aims for mass production and integration of humanoid robots into everyday life by 2027, the U.S. must recognize the need for a cohesive strategy that combines technological innovation with manufacturing capabilities. The potential for a resurgence in U.S. manufacturing, possibly supported by policy measures such as tariffs or industrial strategies, is a crucial point that often goes unnoticed. The interdependence of manufacturing and technology development is essential for maintaining a competitive edge. Moreover, the pressures of political and public sentiment surrounding job losses due to automation will necessitate careful navigation by U.S. policymakers. The challenge will be to foster innovation while addressing the societal impacts of a workforce increasingly replaced by robots. 4. Human-robot interaction and societal integration. Another significant aspect often overlooked is the societal implications of humanoid robots, particularly their design and interaction with humans. The ability of humanoid robots to mimic human actions and learn from human behavior is not just a technical achievement but also a profound social challenge. The design of these robots, how they look, interact, and are perceived by humans, will significantly impact their acceptance and effectiveness. The psychological and sociocultural dimensions of integrating humanoid robots into everyday life could influence their deployment and utility. For instance, the acceptance of humanoid robots in caregiving roles such as in elder care or child supervision raises ethical questions about the nature of human relationships and the role of technology in intimate settings. Understanding these dynamics is crucial for developing humanoid robots that not only perform tasks but also integrate harmoniously into human environments. 5. The broader implications of AI transitioning to the physical realm. The transition of AI from a digital to a tangible presence embodied in humanoid robots signifies a pivotal shift in how society interacts with technology. This evolution raises significant questions about the future of human labor, the nature of work, and the role of technology in our daily lives. The implications of this shift extend beyond economic and industrial contexts into philosophical realms concerning the essence of human-machine relationships. As humanoid robots become more prevalent, societal norms surrounding work, companionship, and even identity may undergo transformation. This philosophical aspect of the robotic revolution is often overshadowed by technological discussions but is equally important. Engaging with these questions early on can help societies navigate the complexities introduced by humanoid robots, ensuring that their integration into daily life enhances rather than disrupts social cohesion. Conclusion. The competition between China and the United States in humanoid robotics is a multifaceted issue that extends beyond mere technological advancements. The economic, ethical, social, and philosophical implications of this race are profound and far-reaching. As both nations pursue dominance in this critical area, it is essential to foster a comprehensive understanding of the broader consequences of humanoid robotics to prepare for the future landscape shaped by this technology. Recognizing the significance of these often overlooked aspects will be crucial for policymakers, businesses, and society as a whole as they navigate the evolving interplay between humans and machines. 1. Market dynamics and projections. The humanoid robotics market is projected to reach $38 billion by 2035, with an estimated 648 million humanoid robots operational by 2050. This growth is driven by the unique abilities of humanoid robots to operate within human-designed environments, which not only expands their utility across various sectors such as manufacturing and healthcare but also creates vast datasets that can further enhance AI technologies. This insight emphasizes the economic stakes involved in the competition between China and the United States, highlighting how market dynamics can influence technological advancements and geopolitical strategies. 2. Technological strengths and strategic approaches. The competition is characterized by contrasting strategies. China capitalizes on its manufacturing capabilities, aiming to integrate humanoid robots into society and industry by 2027. While the United States focuses on advancing AI technologies and software development. Companies like Nvidia are at the forefront of this innovation, developing models that enhance humanoid robot functionality. This dichotomy underscores the importance of both hardware manufacturing and software AI development in achieving dominance in the humanoid robotics sector, illustrating how each nation leverages its strengths to gain a competitive edge. 3. Learning and adaptation capabilities of humanoid robots. Humanoid robots represent a significant advancement in AI learning as they can gather real-world data through their interactions with environments. Projects like Nvidia's Project GR00T aim to utilize human demonstrations to teach robots complex tasks, addressing Moravec's paradox, where tasks simple for humans can be challenging for AI. This point highlights the potential for humanoid robots to bridge the gap between simulated learning and real-world application, suggesting that their development could lead to breakthroughs in AI capabilities that are critical for future technological landscapes. 4. Strategic implications for global leadership. The competition in humanoid robotics is a critical front in the broader technological rivalry between China and the US, with implications for global technological leadership. The US must cultivate awareness of the race and adapt its strategies, potentially through industrial policies or tariffs, to foster its nascent humanoid robotics industry. This aspect emphasizes the need for policymakers to balance innovation in AI with the revival of manufacturing capabilities to remain competitive. Illustrating how strategic foresight and adaptation are essential for maintaining technological leadership in an increasingly competitive global landscape. 1. The Space Race 1957–1975, the competition between the United States and the Soviet Union to achieve significant milestones in space exploration exemplified a rivalry fueled by technological advancement and national pride. The launch of Sputnik by the Soviet Union in 1957 marked the beginning of this race, leading to the US establishing NASA and eventually landing on the Moon in 1969 with Apollo 11. The space race involved not just technological innovation but also deep political and ideological implications, shaping the course of the Cold War. 2. The nuclear arms race 1945–1991. Following World War II, the US and the Soviet Union entered an intense competition to develop and stockpile nuclear weapons. This arms race was characterized by advancements in nuclear technology, leading to the proliferation of atomic arsenals. The Cuban Missile Crisis in 1962 brought the world to the brink of nuclear war, underscoring the stakes involved in this rivalry. The eventual arms control treaties, such as the Strategic Arms Limitation Talks (SALT), highlighted the need for both nations to manage their competition in a manner that would avoid catastrophic outcomes. 3. The Microprocessor Wars 1970s–1980s. The competition between American companies like Intel and their Japanese counterparts in the microprocessor industry exemplified a technological rivalry that transformed computing. American firms initially dominated the market with innovations in chip design and fabrication techniques. However, Japanese companies, through significant investment and advancements in semiconductor manufacturing, began to challenge US supremacy. This competition spurred rapid advancements in technology, ultimately leading to the widespread adoption of personal computers and reshaping global electronics markets. The competition between China and the United States in humanoid robotics is set to shape the future of technology economy and global power dynamics. As both nations intensify their efforts to dominate this emerging field, several key trends and predictions can be identified. Market growth and projections. By 2035, the market for humanoid robots is expected to reach approximately $38 billion, with an astounding projection of 648 million humanoid robots operational by 2050. This growth will be fueled by advancements in AI, which will allow these robots to better navigate human environments and perform tasks traditionally reserved for humans. The increasing integration of humanoid robots in sectors like healthcare, manufacturing, and service industries will drive demand, leading to significant economic implications for both countries. Technological innovations. The race for humanoid robots will see rapid technological innovations. The US will likely continue leading in AI research and software development, with companies like Nvidia at the forefront. Their foundational models will enhance robot functionality, enabling them to learn from human interactions and perform complex tasks. China's focus on mass manufacturing will allow it to produce these robots at an unprecedented scale, leveraging its industrial capabilities to deploy them widely across various sectors. Learning and adaptation mechanisms. Humanoid robots will provide unique opportunities for evolving AI capabilities through real-world data collection. Projects like Nvidia's Project GR00T will enable robots to learn from observing human actions, creating a feedback loop that enhances both robot performance and AI learning. This symbiotic relationship will be pivotal in bridging the gap between simulated tasks and real-world applications. Promoting more effective interactions between humans and robots. Strategic responses and policy implications. the US must adapt its strategies to maintain competitiveness. This includes fostering innovation in AI while revitalizing manufacturing capabilities to match China's scale. Policymakers may consider implementing industrial strategies or protective measures to nurture the humanoid robotics industry during its formative years. There will be a critical need to balance economic growth with social considerations such as job displacement and ethical concerns surrounding AI and robotics. Global power dynamics. The outcome of this competition will have significant implications for global power dynamics. As technology becomes increasingly integrated into daily life, nations that lead in humanoid robotics will gain not only economic advantages but also geopolitical influence. The US and China's rivalry in this sector will likely extend beyond economics, impacting international relations and collaborations in technology. Future scenarios. 1. Collaboration and innovation. If both nations recognize the potential benefits of collaboration, we could see joint ventures in research and development leading to accelerated progress in humanoid robotics and AI. 2. Heightened rivalry. Conversely, if competition intensifies without cooperation, we might witness a technological arms race resulting in increased investment in military applications of humanoid robotics and AI, raising global security tensions. 3. Ethical and regulatory frameworks. As humanoid robots become more prevalent, there will be a pressing need for robust ethical and regulatory frameworks to address concerns related to privacy, autonomy, and the societal impact of widespread robot deployment. Conclusion. The competition in humanoid robotics between China and the United States is not just a technological race, it represents a broader struggle for leadership in the 21st century. As both nations leverage their respective strengths, China's manufacturing prowess and the US's technological innovation, the outcomes will shape the future landscape of global technology, economics, and power. The next decade will be crucial in determining which country will emerge as the leader in this transformative field, influencing the trajectory of human-robot interaction and the future of work.